In this video, I am going to talk about a common physical chemistry practical experiment of undergraduate level. The experiment name is determination of the pH of a given buffer solution by color matching method. Here mainly two terms are there. One is pH and another is buffer. Let us first see what are those terms means. I am quite sure that you all know about these things, but I will try to explain all the terms related to this experiment. So first is pH. pH is defined as the negative logarithm of activity of hydrogen ion or molar concentration of hydrogen ion. That is, pH is equal to minus log of activity of H+. In dilute solution, the activity of the ion can be taken as the concentration. So, pH can be expressed as minus log of concentration of H+ in dilute solution. Next is the buffer. A buffer solution has a constant pH and has the power to neutralize a small amount of acid or base added to it. That is, if a solution can neutralize the addition of small amount of acid or base, then this solution is called buffer solution. Buffer solution are two types. Number one, weak acid and its corresponding salt. For example, acetic acid and sodium acetate. If they are mixed, then they will make a buffer solution, as here the weak acid is used, so it will be acidic buffer. If we take a weak base and its corresponding salt like ammonium hydroxide and ammonium chloride, then it will make a basic buffer. Now let us see how the pH of a buffer solution is theoretically calculated. It is calculated by using Henderson equation. What the Henderson equation is? That is pH equal to pKa plus log concentration of salt by concentration of acid. What is pKa? pKa is the minus log of Ka, where Ka is the acid dissociation constant. If the concentration of the salt and concentration of the acid is same, then we can replace the concentration term with the volume. That is, pH can be expressed as pKa plus log V salt by V acid. Similarly, for basic buffer, pOH can be calculated using the equation pKb plus log concentration of salt by concentration of base. Here pKb is the minus log of Kb, where Kb is the base dissociation constant. Now, if we get the pOH, then the pH of the basic buffer can also be calculated using the equation pH plus pOH equal to 14. This equation can be derived, and I hope that you all know why this equation is coming. Anyway, I will discuss it in a later video. So now let us take an acidic buffer, acetic acid plus sodium acetate, for which we need to calculate the we need to determine the pH experimentally, okay, by color matching method. For that, we need three solutions first. Number one is 0.5 normal oxalic acid solution. Number two, around 0.5 normal NaOH solution, and around 0.5 normal acetic acid solution. For the first solution, I have written 0.5, not around, because we can make oxalic acid solution of exact strength, because oxalic acid is primary standard, but NaOH and acetic acid is not primary standard solution. It will be a secondary standard. I hope you know what is primary standard and what is secondary standard. Once we have prepared the solution, above solution, from there we will prepare exact 0.4 normal NaOH solution and exact 0.4 normal acetic acid solution. Now for the preparation of 0.5 normal oxalic acid solution, say for 100 ml we want to prepare, then how much we need to take the solid oxalic acid. Here you can see that from oxalic acid, here two repressible hydrogens are there, or you can think of like this, there is 2 electron transfer. So the equivalent will be molecular weight divided by 2, and molecular weight here is 126. Why? Because the crystalline oxalic acid, what we commercially get, contains 2 water of crystallization. So the molecular weight is 126 and that will be divided by 2, that is 63. So if we take 63 gram oxalic acid in 1000 ml, then we will get 1 normal oxalic acid solution. So from here we can calculate that for 100 ml 0.5 normal oxalic acid we need 3.15 gram of solid oxalic acid. Now coming to the 250 milliliter around 0.5 normal NaOH solution. NaOH has a molecular weight of 40. So if we want to prepare 100 milliliter 1 normal NaOH, then we need to take 40 gram of sodium hydroxide bead. Okay, NaOH is available as a small disc-shaped bead. So we need to take 40 gram of sodium hydroxide bead. From there we can calculate that for 250 milliliter 0.5 normal NaOH solution we need 5 gram of sodium hydroxide. Now coming to the 250 milliliter 0.5 normal acetic acid solution. The commercially available acetic acid, that is glacial acetic acid, has the strength of 17 normal. But I will ask you, all the students, before preparation of this solution, you should ask your instructor what is the strength of the acetic acid in your laboratory. In general, glacial acetic acid commercially available has the strength of 17 normal. So let's take that 17 normal solution and then from there we will prepare 0.5 normal 250 milliliter acetic acid solution. How we can prepare that? We need to calculate by V1S1 equal to V2S2 formula. So we are going to prepare 250 milliliter 0.5 normal, that is in the left side, and 17 normal is there. How much we need to take? The 17 normal solution, that will give the V2. So V2 is 7.35 milliliter. But it will be difficult to take 7.35 milliliter. So we'll take 8 milliliter glacial acetic acid and we'll add 250 minus 8, that is 242 milliliter of water to prepare 250 milliliter 0.5 normal acetic acid solution. So we now prepared oxalic acid solution, sodium hydroxide solution and acetic acid solution. Next is we need to titrate the prepared NaOH solution using the 0.5 normal oxalic acid solution. Why? Because we need to know what is the exact strength of that prepared NaOH solution. For that, what you will do, This is one of my students' data from last year. What he did is he took 10 milliliter of oxalic acid solution in the conical and he filled up the burette with NaOH solution, with the prepared NaOH solution, and in the conical he added few drops of phenolphthalein indicator and then titrated with that NaOH solution, and he got the data of 10.7, 10.9 and 10.8 milliliter in 3 observations. So this is giving an average of 10.8 milliliter. Now if we calculate this using V1S1 equal to V2S2 formula, what we will find, 10 into 0.5, because 10 is the oxalic acid amount and 0.5 normal was the strength. Now we need 10.8 milliliter of NaOH solution, and what is S2? This is giving 0.46 normal. So the prepared NaOH solution has the strength of 0.46 normal. Okay. Now next what we will do? We will do the titration using this NaOH solution and the prepared acetic acid solution, because we need to know the exact strength of that acetic acid solution as well. So here 10 milliliter of acetic acid is used in the conical and again NaOH in the burette. So here you see 11.5 milliliter of that NaOH was required in the 2 observations. So the student did not perform the 3rd observation, but if the value is different you should do 3 observations. Anyway, here the average value is 11.5. Now from V1S1 equal to V2S2 formula, we will get that the concentration of the acetic acid solution is 0.53 normal. Okay, so we now know the exact strength of NaOH solution and the exact strength of the acetic acid solution. Next, what we will do? We will prepare the exact 0.4 normal NaOH solution and exact 0.4 normal acetic acid solution. For that again we need to do the V1S1 equal to V2S2 calculation. Here suppose for NaOH solution we are preparing 200 milliliter of 0.4 normal. So how much will require? V2, that value is 173.9 milliliter. So what we need to do is we have to take 173.9 milliliter of that NaOH solution which we have prepared earlier, and then we will add 200 minus 173.9, that is 26.1 milliliter of water to get 200 milliliter exact 0.4 normal NaOH solution. Similarly, for acetic acid solution also we will do this similar type of calculation. Here you see, for 200 milliliter exact 0.4 normal acetic acid solution, we need to take 150.9 milliliter of acetic acid solution of 0.53 normal. That we got the strength, exact strength is 0.53 normal. So we will take 150.9 milliliter of 0.53 normal acetic acid solution and we will add 49.1 milliliter water to get the exact 0.4 normal acetic acid solution. So for our experiment, our solution is ready. Exact 0.4 normal NaOH solution and exact 0.4 normal acetic acid solution. Then what we will do? We will take 9 clean test tubes. It is better to use new test tubes of similar size. Why similar size? Because if you use the exact similar size test tube, then you will find it easy to differentiate the color. Otherwise, if the test tube size are different, then you will have a difficulty to get the exact color gradient. Anyway, what I am saying you will find after when I will show one image. Now you see here 0.4 normal acetic acid is used 5 milliliter in every test tubes, and then 0.4 normal NaOH solution is used in the first test tube as 0.5 milliliter, then 1, then 1.5 and up to 4.5 milliliter. We need to make 10 milliliter in every test tube. So what we will do, in the first test tube we will add 4.5 milliliter of water, and second test tube 4 milliliter and so on, and in the last test tube we will give 0.5 milliliter of water. So this will make 10 milliliter of total solution in every test tubes of that 9 test tubes. Okay, now here the pH is given for this test tube. You don't need to calculate here, you can use this exact data directly. So for first test tube, here you see 5 milliliter of acetic acid was used and 0.5 milliliter NaOH. So acetic acid is more, so the solution will be acidic, that's why pH is less. As we are going to the right hand direction, that is in the from 1 to 9th test tube, NaOH are increasing. You see here 1 ml, then 1.5, 2 ml, 2.5, then up to 4.5 ml. As we are increasing the NaOH, the pH will be higher. So here in the number 9th test tube, you see 5.57. Now you see for the 9th test tube, we have here use indicator is bromocresol green. For the first test tube, we have almost yellowish color, then greenish, and then again green, and in the 9th test tube it is dark blue color. So in the examination, you will be supplied 2 test tube with 10 milliliter of solution. What you need to do is to find the pH of that 2 test tubes. Okay, that is your task in the examination. So what you will do, you will add the amount of indicator what you added in this test tube. Suppose here you use 2 drops of indicator, so you should maintain that 2 drops in every test tube. You should not give the indicator in different amount in different test tube, means you have to be consistent. Suppose you have added 2 drops of indicator solution in every test tube. So when you will be supplied with 2 test tubes, of which you need to find the pH, then you will add 2 drops of indicator in that 2 test tube as well. So that bromocresol green in the solution will generate some color, and you will go here and you will try to match which test tube color is matching with those 2 test tube. Suppose number you have been supplied with 2 test tubes, so 1 test tube's color is matching with number 5th test tube here. So number 5th test tube pH is 4.63. So you will write that the first test tube's pH is 4.63, and suppose second test tube's color is matching with the number 8 test tube. So you will write number 8 test tube means 5.23. So second test tube's pH is 5.23. But sometimes there is a problem. What is the problem? You may be confused which test tube's color is exactly matching, because here you see number 8 and number 9 test tubes color almost similar. So if there is a confusion, then you will take the average values of the pH. Means if you are confused with the 8th and 9th test tube, then you take 5.23 and 5.57 and you just average it and report that pH. Okay, here it is written that If the unknown test tube's color exactly matches with any of the test tube 1 to 9, then directly write the corresponding pH. If there is any confusion between two test tubes, then take the average pH. As for example, if you think the color of the unknown buffer can be either of test tube 4 or 5, then write the pH 4.54. Why? Because in the number 4, pH is 4.45 and number 5 is 4.63. So on an average, it is 4.54. I hope you all understood what I said in this experiment. If you have any confusion, you can write your question or queries in the comment box. I will try to answer in my reply. Thank you. Thank you for watching my videos.